Hello, so in a previous video, we actually discussed this problem, which happens to be the 2022 AIME 1 problem 3. We also talked about the AIME process as well, or I've mentioned a few things about the American Invitational Mathematics exam as well. But the thing that I mentioned in that video is that I had found there was another way I saw to solving the problem, but I did not want to make the video too long. So if you want to see the first solution to the problem or see me reading the problem statement, yeah, you can go to that video. But for this video, I'm just going to jump right into the second solution that I had said that I might put in the comment section below or something of that sort. But this is the video explaining that other solution that I found. And so the idea here is that you can, and for this construction, we're actually going to construct a couple of points on side DC. And so I should also say, in this solution, when I use one tick, when I draw a segment and I put a tick on it, that tick will represent it has the same length as AD. In the first solution I presented the problem, I said that would mean it has half the length of AD. So, but in this problem, I'll be using a tick to say that the segment is congruent to AD itself. And so I'm going to first choose a point A prime on base DC so that a DA prime is congruent to DA, right? So DA prime has length 333. And so what I claim about this point A prime, what makes it so special, is I claim that when I construct this point, it will turn out that ADP is congruent to triangle A prime DP. And why do I say that? Well, first, you have that AD is congruent to A prime D, right? The second thing is that because PD is an angle bisector, you get the common angle, right? And the third thing is that DP is congruent to itself, right? Every side is congruent to itself. And so the thing that we get is that it follows now by side angle side that triangle A prime DP is congruent to ADP. And so without further ado, let me actually draw in the third side of triangle A prime PD. And so we can now say, because we know these two triangles are congruent, corresponding parts of these two triangles will be congruent to one another. And so we'll get that this angle is also 90 degrees. And yeah, we'll get this angle is also 90 degrees. But we'll also get that P is the midpoint. P is the midpoint of A prime. Just going to write this over here, right? And so the next thing I'm going to do is I'm going to construct this point B prime so that, I'm sorry, wait, that's actually not good. I'm going to construct this point B prime so that B prime C, okay, so DA prime was congruent to 333. And next, I'm going to construct this point B prime so that B prime C is congruent to 333, right? And so by the same reasoning, it will actually follow that triangle B prime QC is congruent to BQC by side angle side. And so then what you can see is that and so then you can make the same conclusions. You can say that this angle here is also right, and you can say that Q will be the midpoint of BB prime, of segment BB prime. And so now the thing that I will say is that actually you can see that just from this argument as well, you can also see that PQ, it happens to be the midline of the trapezoid. And why do I say that? Well, because AP is congruent to PA prime, the height from P to DC will be half of that from A to DC by similar triangles. And you can see that the height from Q prime, you can see the height from Q to DC will be the same as will be half the height from B to DC by similar reasoning. But you know that because AB is parallel to DC since they're both bases, right, you know that the heights from A and B to DC are the same, and so we'll get that the heights from P and Q to DC will be half of the height from A to DC, and so we'll get that this line PQ basically is parallel to DC, and the distances between it'll be half as close a parallel line to DC as AB is. So that's from this diagram you can actually see that PQ is the midline. So you could, after that, you could actually proceed in the same way, but I'll actually show you a slightly, as we did in the first solution, but I'll actually show you a slightly different way to compute the length of PQ given this setup. And so the first thing I'd like to comment before proceeding any further is that we know that B prime must lie to the left of A prime in this construction when we do this for this particular diagram. And the reason is because D A prime, let's suppose that wasn't the case, right? So maybe A prime and B prime were the same, or A prime was to the left, right? So if that were the case, you get that the sum of the lengths of DA prime and B prime C would have to be less than the total length DC, or most of the total length DC. But you can see that actually given by the given lengths that DC is 650 and each of DA prime and B prime C have length 333, you can see that the sum of DA prime and B prime C actually exceeds the length of DC. So this setup here is not possible. So B prime will have to occur to the left of A prime in our diagram as we drew it. Okay, so that's just a way of determining why that must be the case definitively. And so finally, I claim that given this configuration, right, I actually claim that given this configuration, right here, so you have AB, right, and A prime, B prime. I actually claim that when you take the midpoint, right, and these are parallel, I claim that when you take the midpoint P of AB and you take the midpoint Q of BB prime, that the length of PQ will actually be, or I'll actually write it over here, what it will be. The length of PQ will equal the length of AB minus the length of A prime B prime over 2. And if you actually want to pause the video for a second and think about why that might necessarily be true, I'd actually recommend you to do that if you like. But yeah, no matter whether you want to do it or not, I think it's a good thinking exercise. So really the weird thing that's happening is if it was uncrossed like this, right, and you had A prime was on the left, right, it would just be, PQ would just be literally the midline of the trapezoid A prime, B prime, P. B prime P, I'm sorry, PQ would be the midline of A prime, B prime, B, and so you just get it's the average of A, B, and A prime, B prime. But in this setup here, you actually get something slightly different because these guys are flipped, right? But the way to overcome it is actually you draw these lines in anyways, right? Right, and then the thing is you can actually extend P to meet. You can actually extend line PQ to meet, right? So we know that PQ lies halfway in between lines B prime, A prime, and AB. We've already shown that, right? So when we extend PQ, it'll meet AB prime at its midpoint, P prime, let's call it P prime. Let's say it meets BA prime at Q prime, which will be the midpoint of BA prime, right? And so since now you can look at this trapezoid right here, right? You can look at this trapezoid right here, and you can say that P prime Q prime is the midline of that trapezoid. And so you get that P prime Q prime will be the average of AB and A prime B prime over 2, right? But the thing is now, if you look at these pieces, each of these pieces, right, because if you look at this triangle, this pair of similar triangles, AP P prime and A prime B prime, you get that this is equal to the length of A prime B prime over 2, and you can do something similar to see that QQ prime has length A prime B prime over 2. And so when you subtract PP prime and QQ prime from P prime Q prime, you'll get this formula here for PQ. And so that's how we derive that formula. And so now we can use that formula to find the length of PQ, right? And so we have that the length of AB is equal to 500, right? And so now all that's left to find, the only thing we have left to do is you just have to find the length of A prime B prime, right? And so this is actually basically solved though, right? Because let's look at segment DC, right? In our diagram from up here. And so you get that the ordering of the points will be B prime, A prime, right? That occurs like this. So let's say we call the length of B prime, A prime X, right? Well, it turns out that you know, 333, right? So you have that A prime, dA prime is 333, which means that dB prime will be 333 minus X, and this will be 333. You know, the total length of DC is equal to 650. So you get that 333 minus X plus 333 is equal to 650, right? And so, yeah, and so you basically will get that X is 16. And once you get that X is equal to 16, you know that A prime B prime has length 16. And you can calculate this difference and divide it by 2 to get that PQ is length 242. And so, yeah, I hope you enjoyed this subsequent video we made about the 2022 AIME 1 problem 3. And yes, I hope to see you in future videos as well.